So, question 27 is considering the information in this chapter on B and Z DNA. We're not going to worry about Z DNA in this part of the course, so it's just another rare form of, well, previously thought to be rare, but maybe it's found more often than we know about, than we have known about. But for most of what we're concerned with, DNA exists in the B form, which is what we've been studying, which is the Watson and Crick model, exists in the B form in the cell. At least that's what scientists currently think, and I think they're probably right. So, considering the information in this chapter on B and right and left B form DNA and right and left-handed helices, carefully analyze structures A and B below and draw conclusions about their helical nature. Which is right-handed and which is left-handed. Okay, so let me paste that image in so we can take a look. Copy and paste. Okay. Now we went over this in class a little bit, and I had shown you an image where I had kind of drawn a hand on there, so we could try to determine which one is right-handed and which one is left-handed. So let me see if I can do that again. Let's use this color here. Yeah, okay. This approximately matches the color of my hand, or that's probably more like the color of my hand. But we'll go with that one. Okay. So, if I was going to say, if my hand was really small, or this double helix was really big, and I could grab this helix, what I would do, I would try to wrap my hand around it. So so here's my hand right here. So this is the palm of my hand, and I have 5 fingers, great, okay. And I'm kind of looking down at the palm of my hand, and I've got some lines in here. Okay, so my fingernails are on the other side here. So if that's my hand, and I wanted to kind of just grab this here, wrap my hand around it, so I'm going to put my hand behind there, and I'm going to grab these strands here. This is not a very good color. I'm going to use this color. Okay, there we go. So I'm putting my fingers, wrapping them around the strand. So I want my fingers to touch. I want them to touch the phosphate backbones of this DNA here. And I'm gonna color that in. I'm coloring in my fingers here. Okay. Okay, so my fingers are wrapped around here, but my thumb, I need my thumb pointed in the along the axis of the double helix. So my thumb is going to be like pointed this way. It's going to be like behind here, right? So my thumb's behind there. Okay, can you kind of see that? And my hand is like kind of all back there and stuff. So my hand, you can't really see it, can you? Maybe I can outline it in black. Okay, now you can kind of see my fingers a little better. And then here's my thumb up here. My thumb is pointing in the, my thumb looks kind of funky. My thumb is pointing in the direction along the axis of this double helix here, and my fingers are pointing up towards my thumb. And this is my right hand, right? So this is my right hand. I wrap my hand around that helix. I keep my fingers on the phosphate backbones there, so they're touching it, and you can see that my fingers are pointing up towards my thumb. And if that happens, it's a right-handed helix. Right-handed helix. Okay. Perfect. So this is a right-handed helix. So if my fingers were pointed down towards my wrists, so my wrist would be down here. If they were pointing down here, instead of up towards my thumb, that would be a left-handed helix. In this case, a double helix. So let's see if I can show you that that is true. So I take my right hand, and I'm going to put my thumb along the axis here. So my thumb is actually behind the helix, and my fingers are wrapping around. Oh, I drew my thumb too low. So there's my thumb, and my fingers are kind of wrapping around here. 1, 2, 3, and 4. So it doesn't look that great. Okay, but my hand is wrapping around here, and my fingers are grabbing the strands, and they're pointed down. They're pointing down towards my wrist. And here's my fingernails here, and I can paint them. I can paint them red. No, you know, I would paint my fingernails black if I ever painted my fingernails. My fingernails are there. My thumb is, probably can't see my thumb. Here's my thumbprint up here. Now let me color this in so maybe you can see it a little bit better. And here's my fingers, and they're touching the strand, and they're pointing down towards my wrist here. So this is going to be a left-handed helix. So you notice, and the reason this works is when we're actually touching the strands, if it was a right-handed helix, they would have to be, the strands would be curling up. But no, they're curling down as they're going around the axis. Because they're going down as they're curling around the axis. It's left-handed. If they're curling up as they're going around the axis, then that would be right-handed. At least that's the way I look at it. So what if we pointed our hands? I don't know if this will work, but it could work. What if we point our thumbs in the other direction? You know, does it matter? I wonder if we can rotate this whole thing here. Can we rotate? I just want to rotate. Oh yes, rotate 180 degrees. Well, rotate right 90. Okay, rotate right another 90. Okay, so if we pointed our thumbs in the other direction, and this one over here on the left, you can see the fingers are still pointing, you know, towards the wrist. So yep, that would be a left-handed double helix. And over here, our thumbs are pointed down, but our fingers are still pointing towards our thumb. And because they're pointing towards our thumb, we know that's a right-handed double helix. So I hope that helps you see the difference between a right-handed and left-handed double helix. There is another method, and let me try and do that one right now. So another way to look at to determine if something is right-handed or a helix is right-handed or left-handed, what you could do is kind of visualize it like as a screw. So okay, here's our screw here, and I don't know, it's like one of those crazy, not Phillips head but something else kind of screw, and so you have a screw here, and take that screw and you turn it clockwise in your head, right? So if you're turning that screw clockwise, and when you do that, if it goes, say, into the wall, let's say we're trying to screw this into a wall, we're trying to hang up a painting or something like that. So if it goes in, then it would be a right-handed helix. If it goes out, you know, if you turn it clockwise and it doesn't go into the wall because the grooves are aligned in such a way that it goes out, you know, then that would be a left-handed helix. So that's another way, but it involves you having to kind of look at the helix and try to imagine it as a screw and turn that screw clockwise. If it's a right-handed helix, it goes into the thing you're trying to screw it into. If it's a left-handed helix, it will go out. You have to turn it clockwise in your mind to actually see that and get the right result. Okay, so again, I think those two methods work. You can put down in the comments if you think I made a mistake, but I don't think I did. Okay, So I think I can go on to the Chapter 11 problems now. As I'm sitting here looking at this picture, I can kind of see how you might be a little confused, but I can actually draw the screw, the grooves of the screw a little better, because the way these grooves are drawn, it's kind of like a left-handed helix. So the grooves were going this way, right? We can turn this clockwise, and this one's going to go into the wall, and if the grooves were going this way, we turn it clockwise, this one's going to go out of the wall. So again, this is not a very good diagram, but I think these grooves are more representative of a right-handed and a left-handed helix. But again, if this was on an exam or something, you would have a nice drawing that I found somewhere on the internet that is more clearly representative of right-handed and left-handed helices. Okay, so we've got two methods to tell the difference between a right-handed and left-handed helix. And the reason this is important is because DNA, our DNA in our bodies is right-handed double helix, and it's important to be able to know, to learn the structure of DNA for genetics.